Hello everyone, let's get started. The question is a rod of length 1 meter is released from rest as shown in the figure from this position. Angular velocity omega of the rod is square root of n at the moment when it hits the ground. So at this point, angular velocity is omega. So we are to find the value of n. As we can see, this point is hinged. So that rod, when released, will rotate about this point, about the hinge point. Nothing has been mentioned about the rod uniformity, but actually it should have been mentioned. So we should take that the rod is uniform. Then we can comfortably take the center of mass at the middle point of the rod. So in this position, what will be the potential energy of the rod? We can write that m g and the height. What is the height? Height is this much. Since the rod we have taken as uniform, so center of mass will be at L/2 distance from the end. So this will be your L/2 sine 30 degree. So your H will be L/2 sine 30 degree. H is this one. So this is the potential energy at this location. Now when the rod hits here at the ground, when the rod hits at the ground, it has achieved angular velocity omega. So it means it is having the rotational kinetic energy when it is hitting the ground. Rotational kinetic energy is equal to half I about the hinge point moment of inertia into omega square. This point, hinge point, we can write like this. So moment of inertia for a rod, for a uniform rod, about one end we know that is ml square by 3. So we can write this. So your rotational kinetic energy is this much. Nothing has been mentioned about any friction force or anything. Friction force absent, not present. Only force which is acting is your gravity force. And that is, we know that it is a conservative force. So its energy will be conserved. So we can equate potential energy with the rotational kinetic energy. Thus, whole of the potential energy is changing into its rotational kinetic energy. So we can write from the energy conservation, this rotational kinetic energy is, put the value, sorry, this side we have written potential energy, so we should write potential energy. mgl by 2 sine 30 degree is half. And this side, rotational kinetic energy. That is ml square by 3 into omega square. Your half L. So we got mg by m and m is cancelled. So you got g by 2 on the left hand side, that is LHS. Your RHS is L by 3 omega square. L omega square by 3. So your omega square will be 3g by 2L. So omega will be square root of 3g by 2L. Put the value 3 into 10 by 2. Oh, sorry. L is 1. Yeah, it's okay. And this. Omega is root 15, but at the same time in question, omega is given as root n. So your n will be 15. This will be your answer. So this problem is basically based on the conservation of energy. Here, since your rod does not have any translational motion, it is only the rotation case. So energy has been converted from potential energy to rotational kinetic energy. Hopefully you understood the concept. In case any doubt, please do write in the comment box. Thank you.